So as you know, entity relationship diagrams and relational schemas are pretty similar. They both have these collections of objects with attributes that we need to write down. So the structure is fairly analogous, but many of the simple concepts in ER diagrams are actually pretty subtle to specify in relations. So we'll go through that here over the next few slides, after which hopefully you'll see that it's a mechanical process to convert an ER diagram into a schema. So in logical database design, the first thing to do is to convert entity sets to tables. And that's completely straightforward. Every entity set should correspond directly to a table. And the key of the entity set, in this case SSN, is the primary key of the relational table. Relationship sets are a little bit trickier. Many-to-many relationship sets are pretty easy though. To translate a many-to-many relationship set to a relational table, we create a single table. We name it after the relationship set. So works in, for example. And then the columns that we include are, 1, the keys of every participating entity set. These are going to be foreign keys in this table. So works in, for example, will have a foreign key to employees, which is SSN. It'll have a foreign key to departments, which is DID. And then all the attributes of the relationship set, all those descriptive attributes, are attributes of the relation as well. In this case, the since attribute, which is of type date. Let's just remind ourselves about our key constraints. Remember that when we have a key constraint, what we're saying is that there's participation of at most 1 for everything on the right-hand side of that constraint. Here, every department participates at most once in the manages relationship. So this is a one-to-many relationship. So in order to translate this key constraint down to a relational table, what we're going to do is we're going to think a little bit harder about primary keys. In our prior example of a many-to-many relationship set, we took as the key of the relation the concatenation of all the keys of the entity sets, which in this case would be SSN and DID. But in order to capture the key constraint here, we're going to have a primary key which is only DID. And think about what that does in the relational model. It says that every row in the manages table has a unique DID. Or another way to say this is you can't associate a department ID with more than one social security number. Or department IDs participate at most once in this table. Okay, so we've captured the key constraint of departments as a primary key constraint in the relational model that is the same attributes as the key attributes of the key side of the key constraint in the ER diagram. Another thing that we can do optionally with a key constraint is we can kind of smash together the relationship set manages with the entity set departments that has the key constraint and create a table called deptmugger like we did here, where the key is DID. It's the key from the original entity set. The attributes of both the entity set and the relationship set are there. So we've got DID, DNAME, budget, and since. And we've got the foreign key of employees, SSN, there as well. But by collapsing together departments and manages, we don't have to have a foreign key to anything else. The right-hand side of this relationship set, as well as the attributes of the relationship set, have all been captured in a single table. And this works because of this key DID being the key of both departments and of the relationship set. So let's review the combination of a key and a participation constraint, this dark bold arrow. Every department has exactly one manager, which means that every DID value in the departments table must appear in a row of the manages table with a non-null reference to the employees table, a non-null SSN value. We can map that down to a single DDL statement, as we see on the lower left here. Let's go through it. We can smash together department and manages into a single table, deptmugger. Again, we're going to have a primary key DID for department. And then the SSN field, which is the foreign key to employees, we have to make sure that it's not null. That is to say, we must have a manager for this department manager relationship, okay? Which means that we have total participation of department in this relationship set. There's always a manager for every department, okay? The DID part takes care of the key constraint, and the not null on SSN takes care of the participation constraint. And so we get, in the end, a bold arrow type relationship set. One other piece of SQL DDL syntax here that we haven't seen before is this foreign key on employees has a on delete no action clause. And what that means is that if you were to delete an employee who manages a department, that transaction would be aborted. It wouldn't be allowed. So if you try to delete the reference here, or the thing being referred to, if you try to delete the thing being referred to here, you won't be allowed to. That's what on delete no action means. And so we guarantee the relationship constraint here that every department has a manager. If you want to delete a manager, first you have to delete their department, and only then can you delete the manager. Now I'll note that this worked. We're able to capture this participation constraint with a not null clause, mostly because it's a binary relationship. So participation constraints in binary relationships can be captured in this way in SQL. If we have ternary relationships, life gets more complicated, and we might have to resort to things like check constraints in SQL, which is something we'll learn about perhaps a little bit later.